3.4.
We are.
Wait a second. 3.4. Didn't we just do 3.2? Are we skipping something?
We did.
Why did we do that?
Well, 3.3 just deals with the idea of an atom. It's made up of a nucleus surrounded by electrons.
Right.
Nucleus is made up of protons and neutrons.
Right. So remember, guys, we're following our textbook. And in our textbook, we're just skipping one of the sections, 3.3. So don't panic like, what happened to 3.3? So that's not a big deal. So we're talking about the origin of light.
Yes. We talk about light, but we didn't say where it comes from.
So yeah, where does light come from? So this will be a really short talk. It comes from
atoms.
Atoms.
How does that happen?
You mean light comes from atoms? So we want to learn about where light comes from. Well, light comes from atoms. And so I'm going to be an electron. Do I look like an electron? Okay, I am. An electron in an atom. And Sarah over here is going to just be the energy source. So she's going to like hit me, okay? Not physically, but she's going to throw things at me, okay? So Sarah, go ahead. She throws to me. Oh! It hit me. Oh! I jumped up. I'm on another higher energy level. And I usually don't like to live at a higher energy level, so what was called absorption. I'm going to emit this light, throw it back to Sarah, and as I do that, I fell to the ground, and I emitted some energy. A specific color of light. That was a color of light that went out. So she hit me with the tennis ball. Now she's going to hit me harder with the duct tape. Oh! Ooh, it hit me. Knocks me way up here. Oh! I'm far from the ground. I don't like being far from the ground. So now the energy needs to come outside of me. And so I want to get rid of this. I'm going to throw it away. This will be a higher energy. So maybe it's like purple light. And I'm going to throw this back to Sarah. And boom, I fall back down to the ground, hurt my knees. And no, I didn't. And I emit a greater amount of light. That was emission when I threw at Sarah. And it was absorption as I went up, right? Got hit. I got absorbed. Absorption. Emission. You got it? Good. It actually specifically comes from the electrons in atoms. Now, a little review from atoms.
Yep.
Atoms have three things: protons, neutrons, and electrons. So you might remember from middle school, maybe, or something, that in the center of the atom there's a nucleus. And in the nucleus you've got protons and you've got neutrons. And then somewhere on the outside are these electrons. And they exist in what we call energy shells, sometimes also called orbitals. And they have different levels. We have n equal to 1, n equal to 2, n equal to 3. Why it's n is kind of level. They have the levels are called n. I don't know why.
Bookkeeping. Bookkeeping. Yes.
So there's the electrons. So the electrons, I'll make them green. So I've got a little electron here, and electrons here, maybe some electrons here. So what happens, Dr. Boyer, to make light?
This is an interesting thing. You have to understand that each of these levels represents a certain amount of energy.
Okay.
And so electrons that are in the lowest orbitals have low energy.
Low energy, yeah.
And E is energy, remember. And the higher the orbital, the more energy you have.
Okay.
So an electron sitting up here in the third orbital has more energy than this electron does, which has more energy than this one does.
Okay.
Now, here's the key. What happens if this electron decides to move between orbitals and come down here?
Well, it's going to fall and have less energy.
That's right. But where does that energy go?
I'll bet it turns into light.
That's exactly right. So as this thing moves down to a lower orbital, it loses energy, and that energy goes out as light.
And specifically, guys, it will go out at a specific color of light or a specific wavelength of light. Sometimes you could see it, sometimes you can't.
Yeah, and do you know how much? Well, it's from that famous little equation.
AC over length. We did that just in the last podcast.
So if you know how much energy you've lost, you can figure out what the wavelength of that light's got to be.
So you could actually resolve this problem.
Yes.
You could say lambda is equal to hc over E.
That's right.
And that would give you the wavelength, and hence possibly if it's colored, if it's blue light or green light.
That's right.
Okay.
Most of the time it's not, but you can always figure out how much energy.
So it turns out there's two options. So energy can either be absorbed by an atom.
Yep.
We call that excitation.
Excitation.
Right, so you excite an electron in an atom,
Yep.
or, and that's called absorption. So when we've got our atom with his levels, the electron, make it green again, can be bumped up. and that's called absorption.
It absorbs.
So you can jump from a low level to a high level,
Exactly.
and that's called absorption.
Light comes in,
Also,
it hits the electron, gives it energy, and the electron says, "Ooh, I got extra energy. Let me jump up to the next orbital." That's exactly what it does.
all right, so guys, here's something. I want to take your hands, and I want you to rub your hands together. I've just excited the electrons in the molecules or in the atoms in my hand, and they feel warm now. Why do they feel warm? Now I can't see light coming out of my hands, but infrared light, I am adding energy to those atoms, and it's absorbing the energy.
Yep.
And as I put my hands out like this, it's actually releasing infrared light. Is that
Now it's emitting that light it just absorbed.
Okay. So the other option is, of course, energy can be released when they fall, and that's called emission. So, and Dr. Boyer kind of already talked about that. We've got electrons, when they fall down from the high level to the low level, that's called emission.
Emission.
This is easy.
It gives up energy. Where does it
Absorption
go?
up, emission down.
Down. That's it.
That's easy.
Absorb light, emit light.
So let's watch a short video clip that helps illustrate this. Okay. So here is kind of a last picture in this.
Oh, I like
podcast.
this.
So
This is a
why
nice
don't you
summary.
Talk to me about this, Dr. Boyer.
All right, let's go through this. Here's an example where light comes in, the electron absorbs the energy, and it gets promoted to a higher energy level.
And that's called absorption.
Yeah, it's
going
absorption.
Up. Up
Yep.
is absorption.
Absorbed.
Okay.
And over here, it's the exact opposite. The electron is moving to a lower energy
So
level.
falling down. Got
It's
it.
giving up energy. Where does that energy go? It goes
So why do
in
they
light
make
that's
like that
emitted.
squiggly line there?
This is just the standard symbol for light, and the squiggly line means wave.
Okay, so,
So it's
waves
easy
are
to
squiggly
remember.
lines.
Yeah.
So it gives off a particular color of light.
Right.
Ladies and gentlemen, that's it. Very short podcast.
It is.
All right. We'll see you in class.